All right. Algebra 1, Chapter 12, Section 4, Permutations and Combinations. Okay, these are going to be items. Maybe you're arranging something on a bookshelf. Maybe you're arranging something on the shelf at a grocery store that you're working at. Things that may or may not be important in order, but we will talk about each of those in just a moment. So we're going to start with a permutation. Okay, and a permutation is where order is important. So let's say I have 6 cities that I'm going to visit. Quick little interruption there, no worries. I've got 6 cities that I want to visit, and I want to know how many different ways I can visit those cities. You know, maybe I go to one first, and maybe in the next time I go to it last. So when I look at how many choices I have, okay, I have 6 cities that I'm going to go to. 1, 2, 3, 4, 5, 6. Yes, that's me talking to myself. And so when I look at the first one, I have 6 cities to choose from. Now when I go to the second one, I've already visited one city, so again, order is important, so I have to remove one city from the list, so I only have 5 cities that I can go to. And most of you can see the pattern that's going to form here from 4 to 3 to 2 to 1. And so to look at the amount of permutations I would have for that, all I do is I go back and I multiply these numbers together. So 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. And 360 times 2 is 720. So as crazy as it sounds, I could draw or make a map and go to 6 different cities. I could go 720 different ways. Okay, so pretty interesting. So this is called a factorial. So anytime you see 6 with an exclamation point after it, that just means 6 times 5 times 4 times 3 times 2 times 1. And we'll see some more things over that in just a second. Okay, so let's move on to maybe we're going to do a magazine arrangement inside a library or on a shelf of some sort. Okay, so let's say I would have 10 magazines that I would want to put out on a shelf or a table or anything of that sort, but I only want to put 6 of them out. Okay, so this is going to be a permutation because this is something where order is very, very important. Okay, so it looks something like this. This permutation, oh, let me get my pen back. Looks like this. I have a permutation. I have 10 magazines, and from that, I'm selecting 6 of them. So I'm going to put this into the permutation formula, which you can find on page 765 in your textbook, and it looks like this. N stands for the number of magazines total that you have, and R is going to stand for the ones that you're choosing. Okay, so I've got a permutation of NR, and that's going to equal just what we talked about just a minute ago, N factorial all over N minus R, and then I'm going to factorial that. Okay, so my N, since it's first in my permutation, is 10. My R is 6. So now I'm going to start substituting into my formula. I have N factorial, so that's going to be 10 factorial. Inside my parentheses, I'm doing N minus R, so that's going to be my 10 minus 6. Oh, that's a great 10. Let me fix that. And then factorial outside of that. Okay, so finally, it looks like 10 factorial all over 10 minus 6 is 4, so 4 factorial. Now what we're going to do in this case is we're actually going to write this out. Factorial, again, just decreases by 1 each time. And down below, we have 4 factorial. Okay, now remember, in a fraction, if we have the same thing on the top and bottom, we can cancel them. So we're going to cancel the 4 times 3 times 2 times 1, and then all we're going to take is the 10 times the 9 times the 8, 7, 6, and 5. And that's going to end up being 151,200 different ways. I know that sounds astronomical, but it is absolutely right. 151,200 ways to rearrange 6 of 10 magazines on a shelf. Okay, so that's something where order is important. Now we're going to go into combinations where order is not important. Okay, so we're going to look at combinations. This is going to be example number 4 on page 766. We've got someone who works in a local department. Marquez works in a part-time at a local department store, and he's asked to make a shirt display. Now the reason why order doesn't matter in this one is because it doesn't matter which style of shirt he puts in order. Unlike our last one where we wanted a specific magazine in order, this one doesn't matter. So this is a combination. Okay, so the combination, just like the permutation, is going to be C and N and R. Okay, again, the N here in just a second is going to stand for the number of choices, and the R is how many are we actually going to display. So in this case, he's going to have 8 shirts to choose from, and we're going to display 5 of them in any particular order. It doesn't matter. So the combination formula looks very similar. Okay, it is combination of the number of choices and the one he actually chooses equals n factorial, just like before, all over n minus r factorial. And here's where the difference is. We're going to multiply that times r factorial. So now we're going to substitute in. Again, n is 8. And r is 5. So n factorial, let me do it this way. So we're going to take 8 factorial all over 8 minus 5 factorial times 5 factorial. You'll notice a lot more are going to cancel out on this one because order wasn't important, and so there will be less choices. Okay, so we've got 8 times 7, 6, 4, 3, 2, and 1 to take care of my factorial, all over 3 factorial times r factorial. Okay, so remember we can cancel things. I'm going to go ahead and just get rid of the 5 factorial. And then I notice that 3 times 2 on the bottom is 6, so I'm just going to get rid of my 6. And so that gives me 8 times 7, which is just 56. Okay, so there are 56 different combinations that he can select 5 of those shirts. That should do it. We're just under 10 minutes.